guys, and welcome to the Science Unleashed Users YouTube channel. My name is Tando Ntabati, and if you are a first timer here, thank you so much for tuning in. This is an educational channel where we'll be posting videos on specific subjects such as the physical sciences, mathematics, life sciences, accounting, and geography. We'll also be posting videos of fun experiments that you can try out at home, as well as videos of career guidance, so as to help high school learners determine and guide them towards which career path they should choose. So thank you so much for tuning in, and please don't forget to subscribe as well as hit the notification bell so that you can get notified whenever we upload a new video. And to all our regulars on this channel, thank you so much for tuning in, you guys, again. And your support is really greatly appreciated. And if you're in this channel and you're not really in high school, please do share the videos with someone whom you may think that they might find these videos useful as well, because you want to help as many people and reach as many people as we can. Now, without further ado, let's get into today's video. Okay guys, so today's video is a second edition of our lockdown level 3 science at home about acids and bases. And last week we started off by showing you how to test whether something is an acid or a base using your common household items, and we're using red cabbage as our indicator. And during that video I mentioned briefly about neutralization reactions, and I said I was going to explain what they really are in this video. So to explain what they really are, neutralization reactions are, sorry guys if I'm stuttering a bit. Explain what neutralization reactions are. I explained last week that when you react an acid and a base together, you get a neutralization reaction. That reaction is called the neutralization reaction, right? And your products are going to be salt and water. So what happens is you have an acid which has a hydronium ion, like I explained last week, and you have a base which has a hydroxide ion. And then when the hydronium ion and the OH minus the hydroxide ion, they combine together, they form water. And whatever constituent that is left behind, it forms your salt. So for example, if you're reacting an acid such as hydrochloric acid, HCl, and sodium hydroxide, NaOH, your H plus from your hydrochloric acid and your OH minus from your sodium hydroxide, they combine together to form water, which is one of the products, and your Cl and your Na, which is what is left over, they combine together to form NaCl, which is known as sodium chloride or table salt. You guys may be familiar with that reaction specific. It's a simple reaction, and most of you guys may be familiar with that because maybe your teachers, when they explain this concept to you, they use that as a particular example. Okay, so guys, in acids and bases, there are also special cases where when you react an acid and a base, you don't only get salt and water, but you also get a gas. So for example, if you're reacting an acid and you're reacting a base that contains carbon dioxide, such as your metal carbonate, you're gonna get salt and water plus carbon dioxide. Right, so I'll show you guys a list of different acid-base reactions on the next slide, of which you'll be able to see the different types of reactions as to when an acid is reacting with a metal carbonate or with a normal base, right? Okay, so in an acid and base reactions, we also come with the terms strong acids and weak acids, and strong bases and weak bases. So it's very important for you to know whether you're reacting a strong acid and a strong base, or a strong acid or a weak base, because that determines the kind of products, HS solution that you're going to have in your products. So if, for example, you're reacting a strong base and a strong acid, you're going to have a reaction that is completely neutralized, which means that your pH is going to be 7, right? So it's going to be exactly the same as water, because you're reacting something that's strong and another thing that is strong, so they neutralize each other. But on the other hand, if you are reacting a weak base and a strong acid, the strong acid is going to completely overpower the weak base. So your aqueous solution is going to lie towards the acidic side, meaning that your pH is going to be less than 7. And then vice versa with a base, if you're reacting a strong base with a weak acid, your strong base is going to overpower your weak acid, and then you're going to get an aqueous solution as a product that lies towards the basic side. So meaning your pH is going to be slightly more basic, right? So if you guys are not familiar with what the pH scale looks like, it's basically a number scale where you have numbers between 1 to 14, and your 7 in the middle is the neutral, right? So anything that is less than 7 is going to be an acid, and anything that is more than 7 is going to be a base. So when I say something leans towards the acidic side, I mean that your pH is going to be less than 7, your solution is going to be less than 7. And then when I say something leans towards the basic side, it means your solution is going to be more than 7 because it's a basic solution. So I hope you guys understand the difference between the types of neutralization reactions when you're reacting a strong base and a strong acid, compared to when you're reacting a strong acid and a weak base, or a strong base and a weak acid. Thank you. What happens when an acid and a base react together. So as I explained in our previous video, I mentioned that when you react an acid and a base, you form salt and water, and that reaction is called the neutralization reaction. So what I'm going to do here, I'm going to remove the water, and I'm only going to be left with my acids and my bases, right? So in a neutralization reaction, for something to be completely neutralized, you need to react either a strong base with a strong acid or a weak base with a weak acid. So if you are reacting, for example, a weak acid with a strong base, that reaction won't be completely neutralized, and your solution will take on the color of that strong base, right? And vice versa. If I'm reacting a weak base and a strong acid, the solution won't be completely neutralized, and the solution will take on the color of that acid because it's much more stronger than the base. So here's what I'm going to do now. I'm going to take my lemon juice, and I'm going to take my bicarbonate of soda, and I'm going to, okay, let me just do this. I'm going to pour my lemon juice on my bicarbonate of soda. So as you guys can see, in this regard, for you to be able to test if a reaction is completely neutralized or not, you can check on the color change. So since I've added indicators on all these files, if the color changes to a purple color, which is similar to the indicator, it means the reaction is completely neutralized and is as neutral as our water here. As you can see on this reaction, you can tell that it's either the base is a strong base, or the acid is a strong acid, because the color did not completely change into purple. It's slightly purplish. Okay, now I'm gonna put this aside. Oh, and one thing here that you need to notice, there's something special about our bicarbonate of soda. Did you guys notice that when I was pouring this here, it formed some fizz? And the result of that is because bicarbonate of soda contains carbon dioxide, which is a gas. So if you guys have noticed when you open your Coca-Cola, it makes bubbles. There's some steam that's coming out. So that's exactly the same thing that is here, because it contains bicarbonate of soda. It's going to have some bubbles on. So it's releasing the gas. So I'm going to put this aside. And now I'm going to take my vinegar and my bleach. So I'll pour this here. Okay, so as you guys can see, there was not really much change, as the solution retained the color of the bleach. And that's mainly because the bleach is a much more stronger base than the vinegar. It's a much more stronger base, and it's reacting with a weak acid, right? So the color remains a bit yellowish, like I explained before, that if you're reacting a weak acid and a strong base, the color of the solution is gonna be towards that of the strong base. So I hope you guys learned as much today, and thank you so much for tuning in. Hi guys, and look at what I bumped into here at the lab. So I'm back at the lab today, and this is a chart that shows acids and bases, and it basically explains what I was explaining on the last video. So this is pretty cool. I didn't notice this before, but now that I'm here, I'm kind of noticing, and it's pretty cool. So I hope you guys can see I was doing the right things.